Hey everyone! Today in class we will continue our exploration of finding the least common multiple, but I will demonstrate a unique approach to finding the least common multiple in today's lesson. Let's remember that before this, you and I were listing all the multiples of these numbers, then we were choosing the common multiple, and then from the list of common multiples we were choosing the smallest one and writing it down as the answer. Today, I am going to demonstrate an alternative method for finding the least common multiple. Additionally, I will utilize the identical example to enable you to compare and determine which approach is the most straightforward for you. Okay, find the least common multiple for the numbers 12 and 18. Let's locate it in a slightly different manner. Once again, what were we engaged in prior to this? We listed multiple instances of each of the numbers. Subsequently, we discovered the multiples that were common to all of them during our analysis. And then we picked the smallest number from this list, and thus they obtained the least common multiple. But this trick is not quite convenient, guys. Why? Because when you have numbers with a very large gap, you need to write a big list in order to find common multiples, that is, list a lot of multiples. And then you can locate that smallest one, but now we will do things a little differently, you and me, in a unique manner. How so? To accomplish this, we will remember how to break down a number into its prime factors. So what I'm saying is, you know what I mean, what's up with 12? It equals 6. When multiplying 6 by 2 correctly, the result is 12. However, 6 can also be decomposed into 3 multiplied by 2. In this case, the 2 remains as a separate factor. So it turns out that 12 is the product of 2 multiplied by 2 and then multiplied by 3. I always write numbers in order as it is commonly accepted. Therefore, 12 can be expressed as 2 raised to the power of 2 multiplied by 3. This demonstrates the correct way to multiply and decompose numbers. The process ensures accuracy and consistency in mathematical operations. Why did I write 2 to the power of 2 again? Because there are two 2's here, so I wrote 2 to the power of 2, which means 2 2's. I work with 18 the same. What's up? It's 9 times 2, you know. Once again, I am aware that I can break down the number 9 as the result of multiplying 3 by 3. And the second one is also transferred. So essentially what I'm understanding is that 18 is equal to 3 multiplied by 3 and then multiplied by 2. Well, currently I'm going to write this using exponents. Therefore, 18 is equal to 2 multiplied by 3 raised to the power of 2. Now, to find the least common multiple of our numbers 12 and 18, what do I do, guys? From this record, I choose the numbers with the highest power. So look here, 2 squared, I write down this number, I don't need it now. This number, 2 squared multiplied by 2 squared multiplied by 3. To find the least common multiple, we need to identify the prime factors of each number and then multiply the highest power of each factor. The prime factors of 12 are 2 squared and 3, while the prime factors of 18 are 2 squared and 3. Therefore, the least common multiple is 2 squared multiplied by 3. But in this case, now I'm closing it. In this case, I have a 2, but it's already sitting here. That is, I already have 2, and 3 squared is 2 3's, but I only have 1 3, so I write 3 squared. So it turns out that based on the factors we considered, I choose the factor with the highest power, which is 2 squared, because 2 raised to the power of 2 is greater than just 2 on its own. And 3 raised to the power of 2 is greater than 3. Here is a method you can use to find the least common multiple, LCM. The only thing you need to do here is to count. So I reckon 2 squared is 4, 3 squared is 9, and the end result is 36. So this is the method they use to find the least common multiple in mathematical calculations. I can show this breakdown in a different way to others, so it's really inconvenient to use this decomposition when you have large numbers. So I am going to demonstrate a small portion of an alternative approach. I'm currently writing 12, and I will illustrate this breakdown in a distinct manner. So I put a vertical line and write or think 12 is divisible, and I go through from smallest to 2 to 3 and so on. 12 is divisible by 2, that would be 6. 6 I divide by 2 again. I'm getting 3. 3 doesn't divide evenly into 2 anymore, but it does divide evenly into 3. So in the end, we get a 1. So I am currently going through, or rather setting here, the various factors that the number 12 can be divided into. Let me repeat it one more time. We commence with the tiniest number 2, 3, 5, 7, and so forth, and continue in that manner. So these are prime numbers. I have to divide by these prime numbers in order to solve the problem. To start, I will continuously divide by 2 until my number is divisible by this specific number that I have. I came to the trio. A threesome doesn't divide by 2, so I divide by 3. As a result, I also get 12 equal. Let me list these factors. 2 raised to the power of 2, and their 2 2's multiplied by 3. In the same way, I break down the number 18 into its factors. What is the deal with 18? 18, once again, I divide by 2, I divide by 2, I'm getting 9. I divide 9 by 3 because it doesn't divide evenly by 2, I'm getting 3. If you divide 3 by 3, you get 1. As a result, 18 equals 2 times, a couple of 1s, and I have 2 3s. 2 multiplied by 3 to the second power. And pay attention, this entry and this entry are one and the same. This entry and this entry are also one and the same. This is how you find the least common multiple, so that's how you find the LCM. We'll go over this method together. You'll see it's a practical method for finding the least common multiple. That's it for today. Goodbye until we meet again.